There we go. Okay, good. And looks like I'm out of focus. There we go. Okay, welcome everybody. Looks like we are ready to get started. So we've got some people in Zoom, and it looks like people are starting to come into the YouTube stream. So again, uh, you can watch this however you want. I will be covering actual mathematics today. If you're on Zoom, you're just going to see the green screen behind me. If you are on the YouTube channel, on the stream, then you will actually see what I'm talking about. So you'll actually see the mathematics that I'm discussing. You'll see the canvas. So that's kind of recommended at the very least that you have those visuals available to you. And then just as a reminder, if anyone wants to talk to me after class today, you can. So that would include if you have questions about the class and how the class works. That would include if many of you have started the homework and you're stuck on some homework problems, I can help you with that. So we can go over any of that kind of stuff that you want when class ends, right? So we can get to that at the end of class, right? So we can work on that. Otherwise, today I'm going to be showing you around kind of what you want to get done by early next week. So the things you want to have done by the time I see you again at the very latest, hopefully even earlier. Part of the thing about taking these summer math classes is it's a race, right? Unfortunately, we move very fast in the summer, and you just have to stay ahead of things. So don't get to the point where you start to feel comfortable and go, oh, I can ignore things for a few days, because, each chapter gets harder and harder. So just because you were able to do one chapter relatively easily does not mean that you're going to be able to do the next chapter in that same amount of time. That happens regularly where some people hit a chapter and all of a sudden it takes them 3 times as long as the previous one, but they didn't leave themselves 3 times as much time to do it. So that could be a problem. So make sure you're setting yourself up for success. Make sure you're working ahead of due dates and you're doing everything in plenty of time, and then you shouldn't have a problem. Otherwise, it gets difficult. So I saw that a lot of people have signed up for the homework. I think a little over half the class, maybe 60% of the class, has signed up for the homework. So that would indicate to me everything's working. I haven't had any emails yet telling me that the XYZ homework is not working properly. So as far as I know, everything's working good. Oh, I did see someone, one of my students has been using late passes. The late passes are only... The late passes are only necessary if the homework is already due. You don't need to do a late pass for a homework assignment you haven't done yet. So one person was kind of burning through those late passes, but you shouldn't need those yet because I don't think anything in the XYZ homework is due yet. So, right, let's see. There's a question here. It's not letting me sign on through YouTube, only Zoom. Okay, so there's about 11 people in there. Is there anyone else having trouble getting in? I see that there's people in the YouTube stream. So let me just show you. So let's do it from over here. Let's see. Oh, there's a question about the forums. You don't have to do it the forums in the XYZ homework. Okay. You don't have to do it. You don't have to do the forms that are in the XYZ homework. And then there's a comment here. The book and code is to be picked up at the library, not the bookstore. Yeah, so there's lots of changes going on. So the bookstore and the library, they kind of make this, they decide who's going to cover the books for that particular semester. So it sounds like person is letting us know that you actually go to the lending library to get the book. So that the lending library then is on the 2nd floor of the LRC. The LRC is the tall building kind of in the middle of campus. So you go up the stairs, and if you just go inside to where the part that looks like a library with the books and stuff, behind the desk, just tell them, oh, I'm here for a book that's in my, for this class or whatever, and they'll take care of it at that point. They'll take care of you. Yeah, thanks for pointing that out, Eddie. So let's see. If we go to class meetings here, we've got the 2 things. It should let us log in. So if I click that. So here I wanted to show you. So if you click that link here, it's got the live link. So when I'm live, you can see it live right here. Here's the link that will take you to the live stream. And down here, I added these the other day. I'm teaching 2 summer courses that have Zoom meetings. And so I've created a playlist for each one, and I've created on the right here on the front of the page, it's going to post those playlists. So like for you, you're in college algebra, and let's just say that you miss a class, or you wanted to go back and find something that I said during class, or you go, oh, there's an example that he did in class that I want to see again. You can just go back here, and then the videos will be on this bar here. Like after today, there'll be 2 videos sitting here, and then there'll be 3 and 4, and they just go across the screen. So you can just go back, and you can see that in the name I've put the class and the time, just so you go, oh yeah, that's me. I'm taking V04 at 10 a.m. And then it's got the date. So you can just find the date for whatever day you want to watch, and you can go right there and click it, and then you can watch that. So it's all in a playlist for you. Okay. Yeah, it looks like we're up to about 20 people in the stream. So it looks like it's letting people in. So if you were saying it wasn't letting you in, click that link inside class meetings. It should open here. Click this, and then it should open the Zoom for you. Okay. Let's see. Other than that, let's see, where were we? Yep, and I see that some students are setting up their appointments in the tutoring center. That's great. Keep doing that. I don't want anyone to not be able to do that, so make sure you get those appointments set. That's a good question. So Nicole's asking, to pick up the code and book, are there specific hours to go to VC? Let's look that up. So if we go to, so I'm just on the VC page here, and I go to the library is what we call the LRC. So LRC. So I'll just search for that, and that puts us on the, where are we, kind of here, is that the Learning Center? Actually, is that the right thing? Kind of. So let's see what their hours are. So their hours, they have pretty expanded hours, but they're not like open, obviously they're not open 24 hours. So you've got some hours there. Monday, Tuesday, looks like 8:30 to 6:30. Wednesday, Thursday, 8:30 to 5. Friday, 8:30 to noon. And then closed on Saturday and Sunday. So, hopefully you can get in there at one of those times and get the book and the license picked up. Remember, everyone, even if you don't get the license yet, you don't pick up the book, you still have a 15-day free trial to use the homework. So don't let it get you behind. You can still be using the homework, but then eventually in the next week or so, you're going to need to get the actual license so that it doesn't cut you off at some point. Okay? So that's their hours for the summer right here. Okay. These are good. Any other questions about the course? I know people are still kind of getting comfortable with everything and figuring out what's what. Any other questions? No? Okay. Then let's move ahead. I'll take rolling a little bit just to make sure people are running a few minutes late, I don't miss them. So let's see, where was I? We have that, homework. We're going to look at exams. Okay, yep. And I see many people are taking the quiz and getting the discussions taken care of. That's great, right? Looks like a couple of them are due today. So if you haven't done the class introduction quiz yet, or the getting to know each other, make sure you get in today and get those done. Those are easy points, honestly. I mean, people might miss a couple points or a point on the class introduction quiz. Just make sure you've gone through the stuff and you understand how the exams and homework and all that kind of stuff works. You should do fine on the quiz. And then getting to know each other, that's easy points. Just introduce yourself, and then I think I have you respond to someone else maybe, but just follow the directions, and then you've got some points, and you're starting off with that maybe getting comfortable with people in the class, and that can be a huge resource to doing well in the class. So make sure you're taking care of those. And then we've got our homework. Let's see, and we'll come back to this screen in a moment. But let's go to our calendar just to see what's up. So just as a reminder, on the 26th, that's Monday, your first set of homework is due, your first unit, which is a review chapter. It's largely review, so hopefully you have seen this stuff before and you're kind of going, oh, I have forgotten some of this, but I remember I did this in high school, or I did this last year in a class I took or something like that. But you kind of, if you don't use math, you start to forget it. But hopefully it'll look a little familiar to you and start to come back. So that homework is due. And then on Friday, you have a whole nother chapter. So that just be aware, on Friday, you have a 5-unit chapter due. And on Monday, you have a 6-unit chapter due. So basically, if you want to be working ahead, because if you wait till Monday night to finish the review chapter homework, that means you only have 4 nights, 1, 2, 3, 4, I guess 4 days to do 5 units. That can be kind of a lot. So if you can get the review done early, go ahead and start working on chapter 1 stuff. Okay, even if you only get like 1 or 2 sections completed, then you go, oh, I can't work ahead anymore. That's fine, but that's stuff you won't be having to do Thursday and Friday of next week, right? So that's a good strategy. Kind of think about working ahead. So that's where we are with the homework. This is too wide. Let's do it. There we go. That fits a little better. So you can see that calendar, and you can see, again, we can see the whole thing. If you expand it out to 6 weeks, you can kind of see when everything's due. And that last week is a busy one, right? That 6th week, even though those last 2 chapters are small, they're not necessarily easy. So make sure you're ready for that. Okay, so basically what I did was I just looked over the review. I mean, the review chapter is really like, it's kind of like taking 2 entire algebra courses and like going over everything, right? So I couldn't really leave videos that I thought covered every single detail that you'll need, because that would have been, 100 hours of videos or something like that. So hopefully you kind of remember some of this stuff. It's going to come back to you as you start to look at it, I hope. But I picked specific problems that I know students probably need to see the most, and the ones that I thought were the biggest overview of like the things that are going to come up regularly and that we need to do, and I'm going to talk about those. But I want you to keep in mind one of the best things you can do when you're doing this, like say for example we go to R3 and I'll do the teacher preview, but see in the problems, remember there's a video, an ebook, and a written example. Do not forget about those, because if you have a video that's designed to go with each specific problem, well, that's a huge help, because that video is going to tell you exactly how to do that kind of problem. I mean, the numbers in the video example will be a little bit different than the numbers of the problem that you're working on, but then hopefully if you just follow along and apply what they're doing to the numbers that you have, then it should be, it shouldn't be that difficult, right? So that's a huge help, watching those videos and the ebooks, and you can see they have them for basically every problem. So you should be able to go through and complete those. Okay, so I picked out some problems that I think students struggle with the most. And I think the videos that I posted in the review section over here, these ones cover a lot of that review chapter. So there's, as you can see, there's like, where are we here? There's so like you can see, we've got polynomials, factoring polynomials, and rational expressions. Those are 3 sections from the review chapter. Well, if you look over here, we've got polynomials, factoring polynomials, and rational expressions. So those line up pretty well. And then we've got linear equations. And if you look over here, we have one called, was I looking somewhere else? Maybe I was looking at a different one where there was one called linear equations. But and then we're going to talk about roots a little bit today. So that's a huge portion of that review material that you may have forgotten. We're going to go over in class, but also there are numerous videos for you. Remember, if you go in here and go, well, I don't remember factoring. Well, if you click here, these are old videos. These are sort of videos I made for my classes long before we ever had like online classes or anything. But what I've got here is lots of videos about different factoring techniques. So whatever type of factoring it is that you need, there's a video in here teaching you how to do it. Now, I know that looks like a lot of videos, right? What is that? Maybe like 15 videos, but most of them are like 2 or 3 minutes. So, it's not that big of an investment to go through a few of these videos, especially since you can just find the kind of one that you're trying to do. If you're trying to do one that's factor by grouping, well, look, here's a few that are called factor by grouping. If you're trying to do one that is difference of squares, well, then find these ones that are called difference of squares and just watch those. Like this one, let's see. This is a 40-second video, right? So that's not a very long video in order to have to watch. It's 40 seconds to do that problem. Okay, so those are old videos. Let's see, what else do we have inside of there? There's the so like the polynomial multiplication we'll talk about in a few minutes. I went too far here. Polynomials and polynomial multiplication, those are going to be in here. So you've got lots of things, kind of lots of videos to help you get through this chapter, right? You should be able to find everything you need either between this class visit, the videos that are posted in Canvas, or the videos that accompany the problems in the homework. Okay, so let's take a look over here at some homework. So let's jump to let's go to like roots, radicals, and rational exponents. So what do those things mean? So when we talk about that, we're largely talking about, let me see if I can make this a little bigger, maybe a little easier to see on screen. Okay, so this section is all about things basically with roots in them. Most of the time it's going to be square roots. Occasionally in these classes you might get a cube root, but usually we're talking about square roots. Okay. And then we get these weird things like here, what's 9 to the 3/2? So in that case, the exponent is a fraction. Well, we're going to talk about that. What does it mean when an exponent is a fraction? How do we interpret that? And then if you come down here, you can see you're starting to have to do simplifying with more complicated roots, right? So we're going to look at those. We'll do a problem similar to this one and start to remind ourselves how we do those different steps and how we do these different kinds of problems. So I have a few that I've selected. Oh, and then also keep in mind, I think, what do I have for this chapter? Oh, I don't have one for this chapter, but that's okay. Never mind. Okay, so let's jump into here. So I have this set up so that as it's hard to type math into a keyboard. So it's not exactly a programming language, but it's kind of like a scripting language that we use in mathematics, or some of us use in mathematics, that allows us to type, and then it turns our typing into mathematical expressions. So you'll see sometimes I'll be typing, and then you'll see over here on the screen it'll start putting up like mathematical expressions. That's because it's interpreting what I'm writing. But if any of you have ever even tried to put a polynomial into, say, like Microsoft Word, it's a nightmare. It's the worst. You have to like write it, and then you have to make it a superscript, and then it takes forever. So this is a lot quicker and easier to do. Let me move this over. So let's see. Let me get this out of the way. I prepped a couple of problems earlier. So a moment ago, we saw this idea of fractional exponents. Okay, so remember when we first start learning exponents, the way we think of it is that exponent tells you how many times to multiply the thing by itself. So for instance, if we have 5 raised to the 3rd power, this means 5 this means 5 times 5 times 5, right? So let's see, it'll show up here in just a second. So 5 cubed means 5 times 5 times 5. 5 cubed means you're multiplying 5 times itself 3 times. Now, that helps. That's a nice way of thinking about exponents when you first use them, when you first run into them. But that kind of intuition and understanding of fractions fails you down the road. Actually, let me move this a little bit so I'm facing things a little more straightforward. That kind of thinking fails you down the road. For instance, when you have 5 to the 2/3, does that mean that I'm supposed to multiply 5 times itself 2/3 times? What does that even mean, right? So that early intuition we have about fractions starts to fail us at some point, and we have to think about them in a more advanced way. So that's what we look at right here, right above. We've got this, what is our definition of the fractional exponent? Well, the good news is it lets us write it 2 different ways. There's 2 different ways to evaluate a rational exponent. Sorry, I haven't used this program for a year, not live at least. So I'm getting used to where the certain things go. There's 2 different ways of writing the fractional exponent, and you get to choose whichever one is going to be more convenient for you. So when we write a to the m over n, so that's a written to a fraction, m over n, then what happens is the n, the denominator, is our index of the root, and the m, the numerator, the top part of the fraction, that is our power that we are raising everything to. And you get to decide whether to take the root first and then the power, or the power first and then the root. Oh, looks like I'm getting, sorry. Is that, oh, no, my screen's good. It looked like it was getting cut off, but it's good. So you get to choose which of these to use depending on whichever one is more convenient. Okay, that's really nice because sometimes you look at a problem and you're like, man, I don't want to do it this way. That looks like it's going to be a pain. Well, you can do it in the other order and it'll come out better. So here's an example. So say we want to take 16 raised to the 3/2. So that's the integer 16, and we're raising it to the fraction 3 over 2. Then what happens is the denominator becomes the index out here. You might be looking at that and saying, well, there's no 2 out here. And that's because when the index on a root is 2, we don't write it because that just indicates it's a square root, right? It's a square root, so we don't write that. But if it's a 3 or 4 or 5, we write the index in here to indicate it's not a square root. So, but if you write the 2 in there, it's not wrong. It's just people don't generally do that, right? And then the numerator here, that becomes the power that we can put on the 16. So we can figure out whatever 16 cubed is and then take the square root of that. And that will work perfectly fine, right? The only bummer is then we have to figure out what 16 cubed is, and then we're going to get some pretty big number, right? And then once we figure out what 16 cubed is, then we're going to have to figure out its square root. Well, most of us, if you give us a big number, usually are not going to be able to just look at it and know what the square root is, right? So although we can do, this is the interpretation using this first one right here. I go, I don't really want to do it that way. I don't want to take 16 to the 3rd power and then take the square root. What if I could do the square root first and then raise it to the 3rd power? And that, again, both ways will work, but I think that way is the more clever way to do the problem. It's a little bit, you're working smarter, not harder kind of a thing. So I'm choosing to do it this way, where I interpret 16 to the 3/2 as the square root of 16, and then I cube that, right? And then I cube it. Then I cube that thing. So that's what we're going to do. So basically, the way we look at it then is say, okay, well, if I'm doing the square root first, what is the square root of 16? Well, the square root of 16 is 4 because 4 times 4 is 16. When we talk about the square root, you're asking what number times itself gives you the number that's inside the square root symbol, right? So in this case, we're saying what number times itself gives me 16, and the answer is 4. So this becomes 4 cubed. Equals 4 cubed. It's going to show us just a second. And then 4 cubed is pretty easy to figure out, right? 4 cubed, that means you're multiplying 4 times itself 3 times. So 4 times 4 is 16, times 4 is 64. So this whole answer ends up being equals 64. So, if you just ask someone out of the blue, what's 16 to the 3 halves, most people are going to go, I don't remember how that works. But as you can see, it's actually not very complicated. You just take your root and your power in the order that seems most convenient to you, and then you just simplify them that way. We would also get 64 if we did it this way, but again, we would be dealing with really large numbers that we're not familiar with, and so it just would seem a little bit more complicated. Okay. All right, so let me show you. So when we're dealing with square roots, we oftentimes want to simplify a square root. So let's say we've got the square root of 32, and I want to simplify that square root down a little bit. Okay, well, how would I do that? Well, generally, what we can do is we can separate square roots down into smaller components with respect to multiplication. Can't do it for addition. It's got to be multiplication. But that means we can look at the number 32 and try to break it down into things that are going to simplify nicely. Okay, so in other words, are there any perfect squares that divide 32? And the answer is yes, there's a few of them. 4 divides 32. But we want to find the biggest square, perfect square that we can that divides 32. So remember, a perfect square is a number that can be written as a number times itself. So 4 is a perfect square because it's 2 times 2. 9 is a perfect square because it's 3 times 3. 16 is a perfect square because it's 4 times 4. So what we're looking for is the biggest perfect square that evenly divides into 32, and we want to split it up into those 2 square roots. So while I'm writing this, try to think for yourself. How do you think that we should break down 32? Like how should we break that down to get the biggest perfect square that we can? Okay, and the answer is that we should break it down as square root of 16 times the square root of 2, because that's the biggest perfect square that divides 32 is 16. But we know what square root of 16 is. It's 4, right? We just did that in the previous problem, and hopefully we know that anyways, that the square root of 16 is 4, which means this problem becomes 4 times the square root of 2. So this is our fully simplified answer. So you're going to have times where you have to simplify square roots. This is how you do it. You break it down into the component pieces, and then you simplify the parts that you can. And like the square root of 2, we can't really get rid of that, but that's okay. At least we've, understanding the square root of 2 is a little bit easier than trying to figure out the square root of 32, right? Most people, if you say, what's the square root of 2, they could tell you like, well, it's about 1.3 something, somewhere in that neighborhood. If you ask people what's the square root of 32, they have to go, well, I don't know. Is that like, you got to think about it a little bit longer, right? So that's how you do that problem. Let me go ahead and take roll here. So I'm going to pause for a minute and take roll. So let me first take a look at the Zoom attendance. Okay. No, you're good. I think I can get most of them just by, it looks like most people's names are in there, so in the participants list, so I should be able to get those. What is today? Is the 22nd? Okay. Okay, let me jump over to. Okay, so on the YouTube stream, you only have to enter your name if you are not, if your name was not already in Zoom. So let me start to go through these here. Oh, there we go. Okay, so let's see. Just to double check, I'm missing a. Oh, I thought I saw this name somewhere. Yep, I did. Okay, I got that person. Okay, so I'm missing an Alejandro C, Wendy H, Kendall R, and Fidel S. So if those people are there, get my attention so I can make sure you're not marked absent. Again, I do have to drop after a certain number of absences. Basically, the reason the school takes this so seriously is because most of you paid tuition to take this class, or financial aid paid it or something. But the truth is, the vast majority of the money that it takes to run these classes comes from the state in the form of taxes. Taxes are collected, and then the state pays the colleges to exist, basically. But part of that calculation is based on students in classes. And so the state wants us to drop students who aren't actually attending class because they don't want to pay tax money to pay for students who aren't really coming to class. So that's why they make us clean up the rolls and make sure that we're dropping students. Some of your teachers are not as good about that, but it is in the contract. We have to do that. So just so you know why it's not that we're trying to be mean. It's that they're trying to make sure it's not, they're trying to make sure it's fair in the way that the school gets paid for students that are in there. So I did have to drop some students already. We have to drop students after the first day. Well, in this class, normally it's a couple weeks, but in the summer it's the next day. So some people already got dropped from this class. Other people may in the future get dropped from the class. So basically, to make sure you don't get dropped, come to class and make sure you're progressing on the homework and stuff like that. If you're doing those two things, you're not going to get dropped, okay? If you're not doing one or the other, then you could get dropped from the class. Okay, back to mathematics. This is why we're here. Okay, all right. So this is how you simplify a square root, right? So what happens when you see a problem like this is taken from, I mean, I've modified these a little bit, but these were basically taken from that chapter homework that you have that's due Monday. You're going to have actual homework problems that are similar to the ones we're doing. Oops, I didn't start a new line there. Let's do this to make it a little bit clearer. So In fact, let's go ahead and start a new page. Let's do that. Make it a little bit easier to see. Okay, so we're looking at this one that's the square root of 108 plus the square root of 48. Now, with square roots, you can't just add those together. That does not become the square root of 156. It does not work that way, right? With multiplication, you can sort of divvy them up, but not with addition. You can't do that. Oh, let's see. Oh, someone's saying, okay. Let's see. Oh, I got... Looks like there's some roll. Okay, so we got, where am I? Kendall. R. Okay, Kendall, I got you. Thanks. Oh, and then someone has a question about dual enrollment before we dive into it. I have a question. If you're dual enrolling, do you have to pay? The answer is... See, paying in college is very interesting because everyone's situation is different, right? Some people get a lot of financial aid and everything gets covered. Some people get partial financial aid. Some people don't get any financial aid. So if you're dual enrolled, there should be like my son is actually dual enrolled. He's taking a class at the college this semester. And so we're having to pay some for him to go. So there's tuition that we have to pay. But depending on your situation and there's different programs for different people with different backgrounds and stuff like that. So depending on your situation, you may or may not have to pay, but there probably is tuition in some form. You can check that if you go into your VC portal. You can see if you owe money. Now, one nice thing the school is doing is they don't drop you right away for non-payment, which is nice. It was a pain before. I used to have students that in the first week all of a sudden would vanish from the rolls, and it's because they didn't pay their tuition in time and it just dropped them from the system. So the school has fixed that where they won't drop you for non-enrollment, but what will happen is if you don't eventually pay that, they'll put a hold on your record and you can't register for new classes. So it would hurt you next semester if you don't pay, then you wouldn't be able to dual enroll in any classes next semester or take any college classes or get your transcript or anything like that. So check inside your VC portal. It should tell you what you owe, and then you can pay it or not. And if you have trouble with that, you can contact student services on the campus, and they can help you out with that. Let's see. Here's a question. How do we tell if we've been dropped? Canvas doesn't show the meetings on the calendar. I was checking Canvas for the meeting, so I missed the first class. Okay, so yeah, if someone is obviously trying in the class, if they're regularly attending, if they're making progress on the homework, I'm unlikely to drop that person. But like I say, once you start having 3 or 4 absences, then all of a sudden you're talking about missing, 25, 30, 35% of the class. So I believe what happens is if you get dropped from the class, that Canvas page will disappear for you. So you'll come back someday and that Canvas shell won't be there anymore, and you won't be able to get into it. But it's not like I'm looking here to cut every single person I can from the class, so you don't have to be overly paranoid about it. But just make sure you're showing up to class. Make sure you're participating that you're progressing in the homework. And then you're probably fine, right? And it's not a bad idea. If you have to miss for some reason, go ahead and send me a message so that I know, oh, this person has the flu today and isn't up to coming to class or whatever, right? People have excuses that are reasonable, but if you have excuses every time we meet, then they start to not mean much, right? But you don't have to worry about the absences till you start getting 3, 4 of them, okay? All right. Good. Yep. Throw out these questions to me. These are all good questions, so feel free to keep throwing them out there. So let's see. I'm going to have to do this so I can see it. Let's put it like that and maybe do that. I always have to reformat a little bit depending on the problem. Okay, so how do we break this down? How would we break this kind of problem down? Well, basically what you're going to do is you're going to simplify each of these square roots separately. the way that we did a moment ago. So remember the one that we did up here where it was square root of 32 and we simplified that? You're going to do that to each of these separately. So for a moment, just pretend like it's two different problems, right? We're first going to worry about the square root of 108. So let's worry about that. Let's think about like, okay, so what's the largest thing that divides into 108? And off the top of my head, I don't even quite remember. Let's see. $108 divisible by 16. Nope. Let's see. It's not divisible by 25. Is 108. Definitely 4 goes into it. So it looks like 4. So we want to make that. That doesn't seem right. Is that right? 108 divided by. Okay. So in this case, we've got. We're going to break this down as the square root of 4 times the square root of 27. Because 4 is the biggest square root that divides. I'm rusty with my my typing math skills here. I'll get better here. 4 times 27 gives us 108. And because remember, we want a perfect square. We don't just want any number that goes into 108. We want the largest perfect square. So I checked a couple, right? This stuff seems kind of daunting where students will stare at it for a while. But just like I did, grab a calculator and start seeing what numbers divide into it. So I tried 4. Yes, 4 definitely divides into it. Does 9? Oh, 9 does. That's why. Actually, yeah, I knew that wasn't coming out the way I thought it should. So 9, 2, 18, 108 divided by 30. So 36. 108 divided by 30 is 3. There we go. I was thinking about this wrong. So I think that's what the person in chat meant when they put that there. It was actually ended up being a good answer. So we're actually going to break this down as 36 and 3. Okay, so how did I know to break that down as 36 and 3? Well, like I said, just trying some square roots on your calculator, and I went through them. I went one short. I didn't go quite high enough because I was thinking 36 didn't divide 108. So you've just got your basic squares, right? 4, 9, 16, 25, 36, 49. So there's not that many. So just see if those numbers divide the number that you're looking at, right? 36 does, so it's 36, square root of 36 times the square root of 3. Yep, so thanks to the person in chat who called that out. And so the square root of 36 we can simplify to 6, so it's going to be 6 times the square root of 3. Right, so you can see how the square root of, oh, we got someone else there. Okay, so we've got a square root of 108 simplifies to the square root of 36 times the square root of 3. The square root of 36 simplifies to 6, so we're left with 6 square root of 3. There's nothing more that we can do there at that point. Okay, let's see, I got you there, Fidel. Thanks for signing in. Okay, so we know the first term is 6 square root of 3. So now let's try to break down the second one. So think for a second while I do this about what you think. How should 48 be broken down? So think about, okay, what's the biggest perfect square that's going to divide into 48, right? So you go, okay, does 4 divide into it? Yes. Okay, does 9 divide into it? No. Does 16 divide into it? Yes. 48 is 16 times 3. So we're going to break this one down as the square root of 16 times the square root of 3. Sorry, like I say, I'm a little rusty on the program here. Let's give that a second to recompile. Here we go. So I'm breaking down the square root of 48 as the square root of 16 times the square root of 3. The square root of 16 is 4, so that gives us 4 square root of 3. So the first term, square root of 108, becomes 6 square root of 3. The second term, square root of 48, becomes 4 times the square root of 3. So if you have 4 square roots of 3, and then you have another 6 square roots of 3, then you have 10 square roots of 3, right? You have a total, like, think about like, oh, I already have 4 square roots of 3 sitting in front of me, and someone else just gave me another 6 square roots of 3. So that means I have a total of 10 of them, right? So this whole thing becomes 10 times the square root of 3. That's how you would break all that down, okay? Because we have 6 square root of 3 plus 4 square root of 3 equals 10 times the square root of 3. All right? If you have any questions, feel free to throw them in chat there about a problem I'm working on, or if it doesn't make sense or it's not clear to you. But you're going to have a problem like that. I actually think I even use the same numbers. You have one in here, like here. Right here, square root of 108 minus square root of 48 plus square root of 108. So your answer will come out a little bit different, but it's the same method of doing that problem as we just saw here. Notice how it's telling you how to write things. So it's saying if you want to write the square root of 2, then you'll write it as SQRT and then in parentheses 2. Right? Or it's telling you if you want to do like a cube root, how you would do that. So sometimes students miss those hints, those clues. Whenever you're working on a problem, especially if you are having trouble, look all around the problem, because sometimes there's things to help you. Like here, they're telling you how to type it in. Right? And they kind of, in this case, they're showing you like a detailed, that's probably just for me, the detailed solution. But remember, for you, you've got video, ebook, written example, and then also they're telling you the method. Sometimes I get emails from students saying, oh, I'm not sure how to write it in here. Also, they have this handy little basic tool that helps you write it. So you can either type it in or you can write it in. So notice if I do this and then I hit the square root button, and I can put like 3. So there's square root of 3. Right? See how I did that? So you whichever way you're comfortable with. A lot of people that are, maybe don't use computers as much like to use these kinds of things, like a visual interface where you can click on buttons. People that use computers a lot prefer to generally like to type, right? Because it's faster. You can type way faster than you can click things if you're good with computers. So let's just say I didn't want to use that, and I go, if I do SQRT. See how as soon as I typed SQRT, it put it into the square root? So I didn't click it. My cursor's like up here. I went SQRT, and it formed that square root. So it's giving you a hint for typing it, and then it's giving you, if you like to click buttons, it's giving you that option as well. Okay, great question here. What if it doesn't break down into 2 that can be added together? That's a great question. So sometimes you can't add them together. In this case, we had it where they both broke down into square roots of 3, and that's actually the topic we're about to talk about in just a couple minutes, which is right down here, combining like terms. So when can we add things together, and when can we not? So that's a perfect segue for us to kind of transition into the next discussion. So if one of these terms had been a square root of 3 and the other one had been a square root of 2, then we can't add those together. It would just have been 6 square root of 3 plus 4 square root of 2. That's as simplified as it can get. Yeah. So if they're different square roots, you can't add them together. Okay. Which also, I'll just sort of continue then into our discussion of combining like terms. When can we combine terms and when can we not? So we have to think about this in terms of square roots, like we just saw here, and the very good question that was brought up. And then also we think about it in terms of polynomials. When can we combine like terms? When can we not? It seems really difficult at first, but you'll pick it up pretty quickly and you'll start to recognize it. It really comes down to the right way of thinking about these problems, and if you can do that, then you're usually good to go. So, for example, all polynomials, where am I typing? Here we go. All polynomials take the form of, say, it's some number we call a coefficient times a variable raised to some power. All right, so like in this case, we can see I've got 3x to the fourth. So 3x to the fourth, the number in front we call the coefficient. Then we have the variable and the power that's on that variable. So what happens then is we can start adding these together and say, well, what if I want minus 2x cubed minus 4x plus 7? Right? Then what we do is we use terms that look like this, coefficient, variable, power, and we build up what's called a polynomial, where every term in the polynomial matches that form of coefficient times variable times exponent, right? And if you're observant, you might be going, well, wait a minute, these last terms don't follow that because there's no exponent here and there's not even a variable here, so they don't all fit that form, but they do, because if you think back to our rules of exponents, if we wanted to, we don't normally do this in mathematics, but we could write this as 4x to the 1. That's allowable, right? X is really x to the first power. We just don't really write x to the first power. That's kind of it's unnecessary, right? And 7 we could even write as x to the 0, because any variable raised to the 0 power is 1. So this is a perfectly legitimate way of writing a polynomial. We just don't, because it's kind of redundant. We know that 7 is 7x to the 0, and we know that 4x is 4x to the 1, so we don't write it that way. But in fact, each term is a coefficient times a variable times a power. Now, we talk about the degree of these terms. The degree is the exponent. So this is a degree 0 term. This is a degree 1 term. This is a degree 3 term. And this is a degree 4 term. That will come up more and more for those of you who are going on to calculus. You will see that it's important, right? That you're going to have more and more discussions about the degree of a polynomial, right, as you move through these classes. Also, when we start talking about combining like terms, what terms can we add together and which ones can we not? It's the terms that have the same degree. Okay, that's why I'm introducing this stuff right now. So let's go back to how we normally write a polynomial, like this here. Like that. This is the way we normally write them. So let's say you want to combine terms from two different polynomials. You want to add the polynomials, or you want to subtract them, or something like that. Basically, it all comes down to combining like terms. And so what is a like term? It means the variables have to match exactly. So not only does the letter have to match, but the exponent has to match as well, right? So let's look at some examples. How would that work? Say we had 2x plus 7x. Okay, so what does that mean? I know sometimes for people in mathematics, when we abstract things, that's when people get really confused. Because, like, you know, one thing is, like when you were in elementary school and we could teach you math in terms of food, people get it. Like even when we're teaching you fractions and we divide it up as a pizza or a cake or something like that, people go, okay, I can sort of see if I'm taking a cake or a pizza and we're slicing the pizza into different pieces, that, you know, you kind of get it. But once we abstract things too much, like polynomials, people they lose that ability to visualize the mathematics, and then that can be very difficult. So think about it this way. If we have 2x's and we have 7x's, can we simplify that in some way? Well, what if x was representing a real-world object? What if x was representing apples? Well, if you had 2 apples and someone gave you 7 apples, could you simplify that? Yeah, you'd go, well, I had 2 apples and you just gave me 7 apples, so now I have 9 apples, right? So that makes sense. So if we're doing that in terms of x's, we could say, well, if I had 2 x's and someone gave me 7 more x's, then I would have a total of 9 x's, right? And the answer is yes, that is the correct way to do that problem. You can go ahead and simplify that. When we're adding, what we're really doing is just counting. We're just counting things. Well, I already had 2 x's and someone gave me 7 more x's, so now I have 9 of them, right? That's all we're doing. It does not work that way with things that are different. So 2x plus 7y, what would that equal? Well, think about it this way. What if those were real world objects? If you had 2 apples and then someone came and gave you some wrenches, you say, well, I had 2 apples and then someone gave me 7 wrenches. Do I have 9 of anything? No. They're different types of objects. We can't really count those together. We can't really add them up and say that we have 9 of anything, right? Because they're different. They are unlike terms. They are unlike objects. So 2x plus 7y, that's as simplified as that gets. You can't simplify it any more than it already is. You just have to leave it that way. So you can see when the variables match, we can simplify things. When they don't match, we cannot simplify things, okay? And it's the same way if we have exponents. So what if I had 2x plus 7x squared? Can we combine those together? You go, reasonably a student might say, well, they have the same letter. It's the same variable, but they're raised to a different power, right? You can think of it this way. Sometimes our what if x represents a distance? Well, then x would be a one-dimensional distance, like linear distance. Like we can measure the length of a wall in your room, right? Look around the room you're in and look at a wall. You could take a tape measure or a ruler or a meter stick and you could measure how long that thing is, right? Well, x squared, that's a two-dimensional measurement. That's like area. That would be like how much carpet or flooring is in the room that you're in. And we could calculate that. If you were going to get more flooring put in your room, they would calculate the area and then figure out what to do about it. So if x represents a linear distance, like how long a wall is, and x squared represents the area, like how much carpet you have in your room, does it make sense to add those together? That doesn't make any sense, right? How could you possibly take the length of a wall and add it to the area of your carpet and expect to get something that makes sense? That doesn't make any sense, right? So it doesn't make sense that we would add an x to an x squared, an x to an x squared part. Okay, so these are unlike terms. Those cannot be combined. So when you do homework problems where they have you add polynomials, basically you just look for, is there a term in the first polynomial that is a like term with one in the second polynomial? And if so, then you can combine them. And you just keep doing that. You just keep matching up the ones that are like terms until you have everything simplified down. Okay. Oh, let's see. There's a question here, looks like. Can't we break the root apart, the exponent? We can with respect to multiplication. Multiplication is a whole different ball game. So that's a good question. You might be thinking about multiplication. We can do things with breaking things apart multiplicatively, but it doesn't work for the addition part. We can't break things down addition-wise. But that's a good question. But I think that's probably what you're thinking of is breaking these down multiplicatively, which we could do. Okay, yeah. Okay, so let's take a look now. You're going to do some other stuff, which is multiplying polynomials. So let's remember how that works. By looking at an example. Now here's one that, I try to simplify this, and a lot of times students have learned a technique, especially in high school. High schools are sort of infamous for doing this, trying to come up with, and I get it. My wife's a high school math teacher, so I see a lot of the stuff that they do in the classroom. I get it. They're trying to do it in a way that students remember it. But one of the things you should understand about, I guess I didn't go over this last time because we ran out of time, but it's really key to understand how to be successful in a math class, and you're reaching a level now where memorization is not good enough. Once you start getting to college algebra, and those of you who are going on after college algebra, it's even more important. But even in this class, it's very important. You cannot get through a class like this by memorizing everything. Some of you happen to have really good memories, and it's going to help you to memorize some stuff. But in general, that what has gotten people a lot of times through their K-12 math by memorizing things doesn't really work at the college level because it's too complicated. There's too much going on. So it's really important that you not just focus on memorizing math problems. And I know that's going to be hard for some of you because some of you just spent, 12 years in the K-12 system being told that memorization is how you do things, but it's not. Memorization is, if you think about it, it's not even really useful skill anymore because anytime you forget a formula or something like that, you just pull out your phone and look at it, right? So how important of a skill is memorization? It's not. What's important is understanding the mathematics. And it's more challenging in the beginning, but if you can understand what you're doing, that's going to help you later. When you get confused, you go, well, I already kind of know a bunch of how this works. So then it logically follows that I should do this, right? So it's harder in the beginning and students want to stick to that memorization, but if you can get to the understanding point, it's better. So like when I talk about polynomial multiplication, I'll usually have 5 or 6 students that say, oh, I learned a completely different method for polynomial multiplication. My teacher showed me to do it this way. But really, you're doing the same exact thing. You're just organizing it different. Your teachers probably taught you some way to organize your polynomial multiplication. There's the grid method. There's the box method. There's one called the Chinese method. There's like all these different methods, and it just comes down to how do you write your work while you're doing it. It's not really doing a different thing. You're doing the same exact polynomial multiplication. You're just, some people write it horizontally, some people write it vertically, and some people write it in a box. It's at the end of the day, it's all the same. In fact, sometimes we'll do this in class where I'll have students write they say, no, mine's totally different. And then we write it on the board, and then I'll show them. We go through it, and I say, see this term? See how it pops up over here in this other person's, and it's in this other person's? You actually see all the different math. It's just written in different places, right? So the key is to understand what polynomial multiplication is and not get too hung up on memorizing techniques, right? You need to know the technique, but the most important thing is to know how to do it. To understand like what's happening. Because if you can understand what's happening, it'll usually help you remember how to do it. So the thing about polynomial multiplication, no matter what method you were taught in high school, it comes down to this. You take every term in the first polynomial and you multiply it by every term in the second polynomial. Right? No matter how you write it, whether it's with an X or a box or a horizontal or vertical, we can walk through it and you'll see that what you're really doing is taking every term over here and multiplying it by every term over here. Okay? So for most people, what you probably learned for this method is the most common one is you learn this as FOIL. So if you do first, you multiply the first terms, then the outer terms, then the inner, and then the last. Well, if you think about it, what did we just do? We took each term over here and multiplied it by every term over here. Maybe not in that order, but that's what we did. We did the 4 multiplications of everything over here, got multiplied by everything over here, and then you combine like terms. So let's look at that. So my first terms would be 2x times 3x. Right? That's the terms that are in the front. That's why we call them the first. And then we have the outer. So people remember this as FOIL, F-O-I-L, first, outer, inner, last. So 2x times negative 7 plus, let's see, I may run out of room here and have to adjust. Let's see. So our inner terms, 1 times 3x, so that's 1 times 3x, and then plus our last is 1 times negative 7. Yep, and I am out of room. So let's see if I can get that to adjust a little bit. No, it's still huge. Let's see. Sometimes I have to make the fonts bigger and then smaller because for the problems earlier, I needed a big font. Now I don't need them so big. So let's see. Let's do this. Let's change that. And that means we'll have to change this one. Okay, so now you can see it a little bit better. So we've got our first terms, 2x and 3x, our outer terms, 2x and negative 7, the inner terms, 1 and 3x, and the last terms, 1 and negative 7. So now what you're going to go through is just go through and simplify those terms. Sorry, I got to move it because it's going off the screen there. So we can do this. Right like that. So that will simplify to, that's what? That's going to be 6x squared minus 14x plus 3x minus 7. Okay, so how did I get that? Well, remember 2x times 3x, we multiply the 2 times the 3 to get 6, and x times x is x squared. Okay, now here 2x times negative 7 gives us negative 14x, 3x times 1 gives us 3x, and 1 times negative 7 gets us negative 7. So that's good, we got these steps. But notice we have an issue. See these two terms in the middle, those are like terms, right? They have the same variable and the same exponent, basically x to the 1. That means we can combine them, right? So what if you owe somebody 14 apples? Right? You're like, oh man, I got to pay this person back 14 apples. I borrowed some apples when I was hungry, and now I have to pay them back. And you owe them 14 apples, and you go, well, today I got 3 apples, so I'm going to give you 3 of the apples that I owe you. So how many apples do you owe them? You now owe them 11 apples. So you're at negative 11 apples, right? So then that means for the next step, we'll just go, okay, so the 6x squared stays the same. We now have a deficit of 11 apples minus 7. Okay. Oops, sorry about that. So, we'll simplify down here to this. So 6x squared minus 11x minus 7, that's your simplified polynomial. Notice none of the terms we're left with are like terms. This is an x squared, this is an x to the 1, this is an x to the 0. We can't combine those terms anymore through addition or subtraction. So it's fully simplified, so we're done. Okay. And I think if we go to just so everyone sees, if we go to polynomials, they're probably going to want us, again, they're going to have to tell us how to input our answers. So if we click it, see how you get, here it is. So there's, this x with a box above it. That's your exponent. So if you click that, let's say we make it x, and then I click this, it says, oh, do you want to make an exponent and see how I can put the 2 on there? You can do that. I also bet they have it programmed if I do x. Yep. So there's a shortcut as well if you like to type it. So you can press the button here and put your exponent. Or in mathematics, generally, the caret symbol, which is like that upward arrow, it's on the, if you're looking at your keyboard, it's on the number 6 up above the T and the Y. So if you do Shift 6, it gives you a caret, and that will also act as your exponent. So watch, I'll do it without clicking the button. So I have x, I do Shift 6, and it puts me in the exponent, and then when I put a 2, it says, oh, x squared. That's that you're trying to write x squared. So there's 2 different ways to put that into the computer, okay? So you can do that. So you can see they have you adding some polynomials, At some point, you're multiplying polynomials, and I'm kind of running out of time here, but there was one here. Oh, this one I want to show you. What about a minus 1 squared? Some people get confused about this, and what they try to do is make it a squared minus 1 squared. That doesn't work. That doesn't work. The way you want to think about the problem is like this. Let's do this. Let's make it x minus 1 squared. Here we go. So x minus 1 squared, and people want to make this x squared minus 1 squared. That does not work. It's not the correct way to do it. What you want to do is recognize that x minus 1 squared, well, something squared means that thing times itself, right? So x minus squared really means x minus 1 times x minus 1. So like this. And then when you see, when students write it in this way, they go, oh, I see. So now I'm supposed to FOIL it? Correct. Right. So whenever you see something squared, write it this way, then FOIL it out. And you will not get x squared minus 1 squared. You'll get a different answer. You'll end up with x squared minus 2x plus 1 is actually what you'll get when you multiply that out. But you'll see if you FOIL this. So just be aware of that when you do this one on the homework or this one. That's what they want you to do is write. So for right here, you write this as 2b minus 6 times 2b minus 6. And then you'd FOIL it out, and then you're good to go. Also, this one. See, we have a binomial times a trinomial. So you take every term in here in the first one and multiply it by every term back here. So that's 6 multiplications. So you're going to take everything in here and multiply it by z. Then you're going to take everything in here and multiply it by -3. And then you're going to combine like terms. Okay, that's how you're going to do that problem right there. And then as far as the other ones, there's pretty good videos for factoring polynomials. So you have a couple of outlets. One is that there's videos right here with the problems. Oh, so this one doesn't have a video, it looks like. But this one has a video, right? Some of them have videos, some of them don't. But remember, I have videos, short videos for every single type of factoring. So if you get stuck on one of these, go back to Canvas and find the one that's like what you're looking at. Try to find, oh, it logged me out. Let's see. Try to find the video that looks like the problem that you're working on, and then watch that video. And like I say, these videos are like, so we looked at one earlier that was less than a minute. Some of them are like 3 minutes, so they don't take that long to work through. Okay? And then just sort of go through those. Factoring is hugely important in this class. Do not like think it's okay. Go, well, that's review. If you can't factor, you will not pass this class. It comes up constantly in the other chapters, and in order to complete the problems, you oftentimes have to factor along the way. So like step 1 or 2 of the problem, you might have to factor everything, and then you're supposed to do 3 or 4 more things, but you can't do those other things if you didn't factor it first. You'll be stuck. So make sure you get comfortable with the factoring. If you need additional help, I would go to the tutoring center, the VC tutoring center, and they absolutely, any tutor in there that's a math tutor can help you with factoring. Okay, they're going to be able to help you with that. So they're good at that. So, okay, so that brings us to the end here for today. We are out of time. So I'm going to shut down the YouTube stream, and I'm going to hang out in Zoom. So anyone who wants to talk to me in Zoom, feel free to pop in there and ask me questions about the homework, ask me questions about the class, whatever you want, we can talk about those things. Okay? All right, thanks everybody.